Good afternoon, everybody. My name is Columbus Calley. I'm one of the sales account managers here at Purkeys, and accompanying me here today is Mr. Carl Dessens, who leads a lot of our warranty and technical support. And today is one of those fun days where we get to actually talk about, what we dig into and what we find along the ways, and some stuff that could help benefit you guys, out there on the road. So inverters are always about, providing some of these comforts and everything for the driver. So let's kind of dive into this and see what we got. All right. So when we're talking inverters, it all starts back to the beginning. What is the function of an inverter? Essentially, what an inverter does is it will convert DC power to AC power and provide the driver with that household amenity that they are grown accustomed to using, such as your microwaves, TVs, heaters, coffee pots, you name it. If it's got a plug and runs off AC power, chances are you can probably put it in there. All right, so when we talk about your inverter's wattages, what it can do, what it can withstand. So typically when you hop in a cab, you're probably going to find something, a small college dorm refrigerator, microwave, TV. If you have sleep apnea, then you might see some CPAP machines in there, or other miscellaneous electronics, your game stations, your phone chargers, laptops, printers. But essentially, if you look to the graph here that's on not necessarily a graph, a little chart to the right there, you're going to notice just a general roundabout range of different wattages that most of these appliances will come at. When it comes into factoring, is the inverter that I'm currently using or the one that I'm looking into getting going to work for me, it's good to take these numbers and wattages into account when you're starting to go through and knowing what you're using out of your inverter. Now, your inverter loads, they're going to vary, just like the chart that you saw before. Most inverters that you'll find in cabs and trucks these days are going to be ranging anywhere from 1,000 to 2,000 watts, and in certain cases you'll see those that a little bit more, up into the 2,500 or 3,000 watt range. However, there are two different types of inverters, one being a modified sine and a pure sine, which we'll go into a little bit more in depth a little bit later. But the inverter's main job is to operate, all these AC loads that are being applied to it. But however, some appliances and equipment may not operate as smoothly. And then in the worst case, some can actually even be damaged. So again, knowing what you're using is going to take you a long way. All right. So going through high surge loads or peak surges, typically you'll see a lot of this with the startup of any induction motor or any appliance that has any kind of heating elements, such as your microwaves, your hot plates, coffee pots. So typically it takes a little bit more to get those going, and that's not necessarily saying that's what it's going to be at a running wattage, but as a peak surge or initial starting surge, that's what it's going to require. And the way that I've always kind of factored in what kind of peak surges I would be looking at it. So if I have a microwave that's running at 700 watts, I usually double that wattage to kind of get my peak surge, or what it's going to take to get it to turn on and get those heating elements inside the microwave to start working a little bit more smoother. So again, going back to knowing what we're using, this is also a key thing to keep in mind when either choosing or understanding your inverters.
And I was going to say, Columbus as well, if you're wondering a peak surge, you can relate that to your air conditioner and your home unit turning on, where you may see a little more of a surge and you may see lights get a little dim and then come back. That's what we're talking about on a peak surge.
Right. All right. So trouble loads are a bit of a tricky thing. So some appliances, including some of the ones that are listed below, may be damaged if they are connected to the inverter because of the inverter's modified sine wave output. Now, electronics that modulates, frequency or radio frequency signals on the AC line will not work and may be damaged. So things like this are more commonly assessed with, your CPAP machines, or I've seen some electric blankets that will even cause, some damage. So keep that in mind, and so when you're dealing with something that has like variable speeds or different kinds of settings, high, low settings, such as fans, some microwaves and other electronics, they may also be damaged because, again, it's, operating off of this modified sine wave inverter, which is not going to be able to accurately, kind of push these things along for long terms. Some chargers, for small rechargeable batteries can be damaged as well. If that's something that you choose to keep up with, such as like for your flashlights or, anything that takes any interchangeable batteries. So please, refer to, an owner's manual to, see if that's going to be able to fit properly. And now this is going to lead us to our first poll question. A microwave will only draw in watts what it is rated for. Now, think about this for a few seconds and then choose your answer wisely. You can go through and select the circle by the answer. Clicking on the answer may not always lead you to the right place.
Just make sure you submit it.
Yeah, that too. All right, we'll take a few more seconds here. Okay. All right. Looks like for some reason a lot of our scoring didn't come through. But nonetheless, answer on this one is going to be false because, again, we've got to factor in that peak surge or the high surge that's going to be coming in to get it to turn itself on and start getting those heating elements going. But we will go ahead and continue on.
Yep. So there's some routine maintenance you guys can do as you're in your cab every day. But there's not a lot that is required. But some of the things you should do, you can wipe down the outside of it. You can use a damp cloth. You don't want it soaking wet or anything. That way you're keeping the dust and the dirt off of it. The dust and the dirt will actually reduce the effects of the fans in there, and they won't be able to keep the electronic components cool in there. You want to make sure that those cables are tight, and a lot of this, your maintenance department, as far as the cables tightness and things like that, was going to take care of. You also want to make sure that any ventilation openings on the DC side or the panel, which means that's where your outlets are, or excuse me, that's where your cables are coming in, as well as the ones on the bottom of the inverter, there by the outlets, that they're clean, and that we all have a tendency to stack things up, and sometimes we block our airflow. So we just want to make sure that, or you would like to make sure that you have plenty of airflow. That way we're at the same time, we're keeping that cool, keeping air circulated, and getting a long life out of that inverter. So we're having problems with the inverter. What's the first thing I need to do? Well, first thing you want to do is disconnect your loads. You can unplug them, make sure everything's good in that way, that all of them are off. Start your truck. And what starting the truck is doing, because a lot of these have some type of a low voltage disconnect, so say I get down to 12 volts, I'm going to turn the power off to my loads. So when I start the truck, it ensures me that we are above 12.6 volts. We've got good power going to it. And then if there's a switch, either an on-off switch or some type of a switch on a control, you want to cycle that on and off. And at that point, once you cycle it on and off, you should be able to see if you're coming back to your green lights, everything's working. You can put the load back on and see if you have the operation there. If none of that works, then we need to be talking to our maintenance departments. So here's another question. What's the suggested way to reset an inverter? Are we going to restart our truck, restart it, turn the unit off and back on, disconnect the batteries, or there's not a way? So as you're looking at that, thinking about this, let's go ahead and let's make some answers here. Give you a few minutes to go ahead and do this, or a few seconds, excuse me. All right, looks like we're good in knowing that we need to turn it off and back on and move forward. So let's talk a little bit about the difference between a modified and a pure sine inverter. Now, a modified sine inverter is a good inverter. It's going to protect your truck, it's going to protect your batteries, and the biggest thing about them is they're cost effective. They don't cost quite as much as a pure sine. But the pure sine inverter, we've got an increased protection for the truck and the batteries. Okay, we can increase the use time on it, and it also is easier on your appliance and electronics because that's where we get a surge from. So you'll see an inverter rated at, say, 1,500 watts with the 3,000 surge. So that means where Columbus was just talking about that increase or that bump when you first turn an appliance on or something like that, it's going to allow you to go up to that 3,000 watts and not shut everything off right away. That's part of what we look at when we're looking at the pure sine. So it does aid in allowing more usage. So that modified wave inverter, you're going to be able to power most electrical devices. So, you know, I want to do a TV, want to, you know, charge my computer, run a DVD player, some of those things, game console. It's not going to have a problem. Your microwaves, you may, depending on the size of the microwave, but now they're not quite as efficient as that pure sine inverter. So you're going to see more heat, which can lead to that premature failing, either of the appliance or the inverter, and as well as a shorter runtime, meaning it's a quicker shutoff, and that's due to overheating protection inside. That's why another reason we want that good airflow. Now, when we look at a pure sine, we compare it. Now, this happens to be our more efficient inverter. So when I'm using the refrigerator or the microwave device, something that has a motor in it, it will handle that short surge and still maintain that power. Your medical devices, CPAP machines, are the same way. It will take that surge. It's going to give you more of a, as it says here, a pure sine or a more consistent wave if I'm looking at this on an electrical scale. So here's the next question that we're going to ask you is, what's the best inverter for a medical device? Is it the pure sine or the modified sine? Let's give you a seconds or about a minute or so, and then we'll look to see where we're at. All right, you guys are seeing pure sine is definitely a better way to handle some of these different devices. So we're going to look at, in this case, some of the devices and some of the troubleshooting, little things we can do. On our modified inverter that we sell, you can actually see the LEDs, and that's also for your low voltage disconnect, which is what LVD stands for, as well as, is my unit on? Do I have an output fault? And the output fault means I actually have no output to my outlets, and that could be because of a surge, an overload, things like that, as well as an input fault, which has to do with power coming in. So want to make sure if I do have that, you see that red button there, disconnect my loads, and that's actually where I can turn around and restart that unit. So on these particular fault lights, we've got a green light on. It tells me that unit's ready to go, good to go. If I am flashing, that tells me I've got 30 seconds before it's going to shut off. And this is especially true when I'm looking at a low voltage disconnect. That tells me that my batteries on that truck are getting low. I'm going to shut down. Part of the reason we use that low voltage disconnect is so you can restart that truck when it's time to go again. If my red light is on, tells me I've got low voltage to the inverter, so my battery voltage may be low. Once again, let's start and run that truck. Get your voltage above that 13.2 volts. Obviously, with some of the idle shutdowns and things that are out there, you're not going to be able to run it very long, but that'll get you at least to that 13.2. If we have an input fault, that means we have more voltage going to it, and we're going to protect that. So if it gets above 15 volts, then we're going to throw that input fault in. It's going to protect not only your devices, but protect the inverter from a problem as well. Then if I have an output fault, now we're telling us that we've got a little more load than this thing is going to handle, or I'm over temperature on the inside. So things that we have to watch out for with those. Pure sine diagnostics. We're going to talk about this. Columbus and I are going to kind of handle this one together here. So,
all right. Okay, so kind of going in with a lot of these newer inverters and stuff that are coming out now, having some type of a remote or a controller has made things a lot easier as far as understanding, what's going on with your inverter. So if reading on through this, when you get a blinking fault light on one of these controllers, typically it's labeled there, so it's usually easy to identify, but it means there's a communication fault. Now, communication fault, what does that mean? Well, it could be because of the Cat5 cable that's connecting that controller to the inverter is either damaged, it's not, plugged in all the way, or, it could have a pinch in it or something like that that's causing, momentary power, disconnect, or it's just broken the circuit completely. So definitely keep your eyes on it if you ever see that. Go ahead.
I was going to say, the main thing is, though, if it's plugged in to both the control and the unit, now you're going to have to get to your repair location or get in touch with your maintenance on that. When you have that LVD light, and you can see here, that's in this case on the controller that goes with the Purkeys 1500 and 2000 watt inverters, that's that second one from the left. So that means we've got low battery voltage. We've run it to the point that it's hit the shut off where that control has been programmed for. So once again, take some of your loads away, start the truck to charge your batteries, and if it continues to happen, and it can, once again, let's get with that repair facility and so they can make the repairs to it and check it out a little bit further.
Okay. Now, when we're talking a blinking fault and a solid LVD light, This is when we start getting into the combination of different lights that are going off and on. It can kind of put you in a trance if you stare at it too long. But what it all boils back down to is the voltage at the back of the inverter is going to be, below 9.6 volts, or it's going to be so low to the point to where the inverter itself is not registering that it's got a good power source. So typically, if you turn the inverter off and then turn it back on, usually it can kind of reset some of this and kind of pick back up where it left off. Usually gives it a chance to kind of re-register that voltage that's coming in. And then, of course, if you're still seeing issues, again, like Carl was saying before, make sure that you get that in to have it looked at, just because there's no sense in taking a chance on something like that.
Right. And at this point, you get the blinking fault in solid LVDs, you're not going to have any output on your inverter. So it can create problems with food in the fridge, different things like that. So now if I get the fault in source light, okay, I'm talking about a blinking fault light, a solid source light. This can actually be caused by jump starting a vehicle. So what happened is we've got a high voltage surge there. Usually it could be over temp as well, and that's where we're getting that improper airflow to that unit. So like I said, we want to keep that area around it clean. Either way, whatever it may be there, we want to shut the inverter off, give it some time to cool. Could be a few minutes. It could be, I've seen it as quick as 2 or 3, but generally you're going to be at least 5 to 15 minutes to allow that thing to cool back down some. All right, restart it. If I do have both those lights come back on, I need to be getting to that repair location. Okay, your maintenance shop and your repair here is the key in all of what we're doing. Like I say, for the driver in this case.
Okay, now when we're talking, a blinking fault and a solid load light, this is typically caused by overloading an inverter. Now, it is very easy to do so if you're not careful, and usually you'll find that with a power strip and you've got a whole buku of plugs plugged into it, but going back to the very beginning of this webinar when we started talking about different wattages, understanding those is going to help you help prevent these LED scenarios from popping up. So how do we combat that? We start removing some of the loads, possibly shut it down for a bit, let it kind of cool back down, start it back up, allow it to have a fresh start at being able to handle what you're throwing at it, and then that should carry you the rest of the way on that. Now, this kind of leads us into yet another poll question that we have for you, and in probably the simplest one of them all. Would you recommend this information to other drivers? What you've listened to us talk about today and what you've kind of learned along the way, is it something that you would feel comfortable, pushing to, fellow drivers or companies in that matter?
Would it be a benefit for them to learn some of these little troubleshooting tips and make it easier, not just for you to understand how it works, but for them as well? It also helps when you understand it to help your maintenance shop as they're trying to diagnose the problem you've got. So just something really quick in that. We're going to look. Do you guys have any questions or anything related to that we have missed, or something you're curious to know about? The inverters that we have, or that Purkeys sells, for the most part today, for the most of them, are the modified sine. We have found they've been very reliable and been very beneficial in keeping all the creature comforts in the cab up and running. And that's what part of it is. When a driver's out on the road, that is his home, and we want to make sure you have what you want and be able to live life on the road easier.
Absolutely.
All right.
Well, again, want to thank you guys for, kind of tuning in and listening to us, kind of ramble on about some of this stuff. If you wouldn't mind, hang tight for a few minutes after this, and we will have a little bit of a survey there for you, looking for, some kind of some feedback and what you guys might want to see, going forward on future webinars. But again, thank you.
Thank you. This will be loaded onto you'll get a link within 24 hours. So if you didn't get to see it or want to see it again, you can review it. It'll also be loaded on our website. So we want to thank you for spending some time with us, and hope you learned, and this is your benefit. So please take the time, answer questions for that, and we'll see you next time.